Okay, this is Chapter 12, Section 3, Inscribed Angles. We've talked about central angles, which the vertex is at the center. Today we're going to talk about inscribed angles. It is an angle whose vertex is on the circle, so like this guy here. An intercepted arc is an arc that your inscribed angle hits. So this angle makes this arc. If an angle is inscribed in a circle, then its measure is half the measure of its intercepted arc. So, for example, an angle there. So this angle is an inscribed angle. It is half the measure of this arc right here. So when we want to go find, So when we want to go find what the measure of this arc is going to be, we say the arc is twice the inscribed angle. And 2 times 37, 74. Searching for that one. Okay, so here it is. We have 112. If we want to find the measure of this arc, it is going to be 2 times 112, which is 224. Okay, so lastly but not leastly, we have this 90-degree angle. We want to find the arc that is intercepted by the 90-degree angle. It is 2 times 90 degrees, which we know that one. That's a semicircle. It's 180. All right, let's do that process backwards. Let's use the arc, cut it in half to find the inscribed angle. So if this arc is 110, we're going to cut that in half and go 110 divided by 2, which means our inscribed angle is 55 degrees. All right, we have a diameter situation. Remember, if we have a chord that goes through the center, that is the diameter. The diameter always creates an arc of 180 degrees. So half of 180 is 90. And watch this little crazy bugger here. So if arc AB is 72, so from here to here is 72, it's our arc measure, what is the inscribed angle ACB? ACB? Oh, it's going to be half of 72. So it's going to be 36. Okay, now what is angle ADB? So let's go ahead and see what that's this line. Oh, it also intersects the arc of 72. So it is also 72 divided by 2, or 36. How interesting, huh? Okay. So if two inscribed angles of a circle intercept the same arc, just like this picture here, then the angles are congruent. You know that these two angles are going to be equal because they touch the same arc. They open up to the same arc. All right, let's write down some corollaries to theorem 12.11. If a right triangle is inscribed in a circle, put that down here. Okay. Then the hypotenuse is a diameter. Then the hypotenuse is a diameter of the circle. Conversely, if one side of the inscribed triangle is a diameter, then the triangle is a right triangle. So if you are in the diameter realm, you're going to create that right angle. So if a right triangle is inscribed in a circle, the hypotenuse has to be the diameter. let's look at this crazy thing. Quadrilateral, remember, is a shape with 4 sides. It has 4 sides. It doesn't necessarily, normally we think of quadrilaterals as like rectangles or squares, but it doesn't necessarily have to be a rectangle or a square. It could be a trapezoid or a parallelogram. They're all in the quadrilateral family. A quadrilateral can be inscribed in a circle if and only if the opposite angles are supplementary. Remember, the supplementary means it adds up to equal 180. So E and D have to add up to equal 180 if this is truly a quadrilateral that is inscribed. Also, F and G have to add up to equal 180 as well. So let's use that property to find some missing angles. For example 3, we're going to find the value of the variables in the following diagram. So we have this triangle here. We see that the hypotenuse goes through the center. So then we can say, and just ignore that, pretend like this goes all the way over here, and touches it. Okay. We are going to go, well, if this is a diameter, then this has to be 90 degrees. So x has to be 90 degrees. If x is 90 degrees, and this is 40, then we know that 90 plus 40, I know that looks like a 90, it is not. Let's make it look more like a 40. 40 plus y has to equal 180. So 130 plus y equals 180 minus 130 from both sides. Y is equal to 50 degrees. Okay, we are, that was this corollary 2. We're going to use corollary 3 to find our missing angles. We know that x and 100 are supplementary. They add up to equal 180. So we can say x is equal to 80 degrees. We know that 3y and 120 is equal to 180. So when we solve for y, we can say, divide by 3, we can say y is equal to 20. I guess it's not really at a degree because it's next to 3. Okay, one more. Okay, so let's check this guy out. We're going to add some algebra skills in here. I know, you guys, so exciting. It's been so long since we've done this. So 3y plus 3x is equal to 180. And we know 2y plus 5x is also equal to 180. And you're like, Ms. Albagar, no, nothing. We can't do this. We're done. We solved. We actually can do this. We're going to solve using elimination. So I'm going to use a multiplying factor to get rid of my y. So I'm going to multiply the top by -2 and multiply the bottom by 3. When I do that, watch what happens. I get -6y minus 6x equals -2 times 180 is -360. And then 3 times 2y is 6y. 3 times 5x is 15x. And 3 times 180. Well, let's get the calculator out. Oh, you can see I didn't have my calculator ready. Because it takes time. 3 times 180. You're like, this was in the last video. I know. 3 times 180. It's 540. All right, so now what we're going to do is we are going to add our columns together. -6y plus 6y is 0, so the y's cancel. negative 6x plus 15y, sorry, negative 6x plus 15x is 9x, and negative 36 plus 540, negative 360 plus 540 is 180. Oh my goodness, is it Friday? I think it is. Divide both sides by 9, and x is equal to 20. We are not done. Just knowing x is equal to 20 doesn't mean we have solved for y. So we need to pick one of these guys. Let's go ahead and pick the second one. So we got 2y plus 5 times 20, because we know that now, equals 180. 5 times 20, oh, I know that is 100, equals 180 minus the 100 from both sides. 2y equals 80, divide by 2, and y equals 40. Woo! That's good stuff. All right, one more theorem. If a tangent and a chord intersect at a point on the circle, then the measure of each angle formed is 1/2 the measure of the intercepted arc. So if we look at angle 1, it intercepts A and B. So if I want to know what angle measure angle 1 has, I just take this arc measure and cut it in half. Conversely, if I want to know the measure of arc AB and I have angle 1, I just double it. But we have another beautiful piece of it. This guy here, BCA, angle 2 is equal to half that arc. So we get 2 for the price of 1. We know what angle 1 can be, and we know what angle 2 can be. So let's take a peek at some example problems. We're going to find the value of variable or the indicated arc. All right, so we want to find x here. It's this angle. We intercept the arc. That is 150. So the measure of angle x is equal to 1/2 times 150. Half of 150 is 75. All right. We want to find the measure of arc RSP. Well, the angle that intersects it is 130. So we go 130 is equal to 1/2 the measure of RSP. So to get rid of a 1/2, we just times it by 2. So we're going to double 130. So the measure of arc RSP is equal to 260. Wow, nice. Okay, let's look at our last problem here on C. The measure of angle ABC is 64. The measure of ADB is 4x plus 10. Arc ADB is 4x plus 10. So we need to solve for x and also figure out what, I guess we just need to solve for x. So let's take this arc here. If its angle is 64, then the measure of arc AB is 2 times 64, which is 128. So that is this arc here. What is left when I give that 128 degrees to arc AB is the arc that is intercepted by 4x plus 10. So when we take 360 minus 128, we get 232. Okay, so we know 4x plus 10 is equal to 232. Minus 10 from both sides. 4x equals 222 divided by 4, and x is equal to, get the calculator, 222 divided by 4, 55.5. I guess we'll say degrees. Okay. Take a moment, go work on your practice assignment for this section. When you are finished with the practice assignment, come back here and check your answers. Let me know if you have any questions. Here is the answer key to 12.3 practice, page 784, 6 through 20 even, 25, 35 through 37.